Graphing in Three Dimensions by Rece Allensworth and Olivia Henderson. Introducing you to a whole new dimension.
Now you might be asking, what even is a 3D graph? So let me tell you. The main difference between graphing on a 2D graph and graphing on a 3D graph is the amount of quadrants or sections divided up by the x, y, and now z axis. On a 3D graph there are 8 sections called octants. On a 2D graph there are 4 sections called quadrants.
The equation we will be exploring today is f of x and y equals x squared plus y squared. Now, to get the points on the graph, you need to set up a table where x and y are your inputs and z is your output. We will start where x is negative 5 and y is negative 5. So we plug in negative 5 for x and y and use order of operations to figure out what f of x and y equals. Negative 5 squared equals 25, and negative 5 squared equals 25. Add those together to equal 50. In the table, it would look like this, and as a coordinate point, it would be negative 5, negative 5, 50. Again, but now x will be negative 4 and y will be negative 3. Plug them into the equation. Negative 4 squared plus negative 3 squared equals 16 plus 9. Add those together to equal 25. In the table, it would look like this, and as a coordinate point, it would be negative 4, negative 3, 25. Continue to fill out the table with both positive and negative inputs.
When plotting a point on a 3D graph, it is quite similar to plotting on a 2D graph. There are 3 values when plotting a point on a 3D graph: x, y, and z. First, you go x units in the x-axis direction, then from there you go y units in the y-axis direction, and lastly you go z units in the z-axis direction. For example, to plot the point 1, 1, 2, you would go to positive 1 on the x-axis, then positive 1 on the y-axis, then positive 2 on the z-axis, and mark the point there to look like this. If you were to continue to plot more points from the equation, then connect all the points, you would get a graph that looks like this, a 3-dimensional parabola, if you will.
To explore a modified equation, we will take you through the equation f of x and y equals 1/4 times x squared plus y squared. Just like the previous equation, you need to create a table where x and y are on one side for the inputs, and one where z is on the other side for the outputs. Then plug in numbers to the equation. For example, plug in negative 4 and negative 4. Negative 4 squared equals 16, then again, negative 4 squared equals 16. Add those together to equal 32. Then multiply by 1/4, and that will get you 8. In the table, it looks like this, and as a coordinate point, it is negative 4, negative 4, 8. Then continue to fill out the table with both positive and negative inputs.
Graphing point by point, just like the first equation, then connecting all the points together. You will get a graph that looks like this. This is different from the first equation because this equation is dilated horizontally by 4, making the graph look stretched out.
Connecting this back to the real world, a famous YouTuber, David Dobrik, made a recent video with a scientist named Nick Uhas. They used 3D graphing to determine the volume of an elephant toothpaste experiment done in David's backyard. They measured the width and length of his backyard and used camera angles to determine the height at which the toothpaste would reach. By doing so, they used 3D graphing to determine the volume of their experiment.
Olivia and I felt that 3D graphing would allow us to challenge ourselves as best we could, but still accomplish our goal of learning a college-level math unit. Doing this project didn't just enhance our understanding of a 3D graph, but also helped further our understanding of graphing in general.